Hello students, welcome back. Today we will continue with number system and the topic for discussion would be real numbers and their decimal expansions. Okay, so just to revise, real numbers are categorized into natural numbers, whole numbers, integers, rational as well as irrational numbers, right? Now, natural numbers are counting numbers like 1, 2, 3 and so on, right? Whole numbers are nothing but from 0 and all natural numbers. Integers are again, they include both the negative as well as the positive side of your number line, right? So, they start from minus infinity, minus 3, minus 2, minus 1, 0, 1, 2 and so on until positive infinity. So, you see that all of these can be represented in the form of fractions like 1 upon 1, 2 upon 1. Similarly for whole numbers as well as integers, right? So, we can express these as rational numbers, that is in the form of p upon q, but rational numbers are actually fractions, p upon q, right? For example, I will say 1 upon 7. Now, you cannot write 1 upon 7 as 7 or 1, right? So, this is a fraction. That is why dividing 1 by 7 is going to give me decimals. Similarly, for irrational numbers, we know that root 2 is approximately equal to 1.414, right? So, we have decimals here. So, you will notice that amongst all your real numbers, you will find decimals only in rational as well as irrational numbers, but not in natural numbers, whole numbers and integers, which is why we are going to look at the decimal expansions of rational numbers and irrational numbers, right? So, since we are familiar with rational numbers, let us take a look at rational numbers, the decimal expansions of rational numbers. So, I am going to refer to page 9 of your textbooks, the solved example number 5. Find the decimal expansions of 10 upon 3, 7 upon 8 and 1 upon 7, okay. So, the first one, 10 upon 3. This becomes the dividend, that is 10, and 3 becomes the divisor. So, let us go ahead and divide and see what we get. My dividend goes inside, so this is 10 and I have the divisor outside which is 3. So, let us divide. 3 3s are 9. Right. Now, 3 won't really divide 1. So, what I do is I put a decimal here and I put down a 0, right. So, 3 3s are 9 minus 1. Again, I take a 0, 3 3s are 9. Now, since I added another 0 over here, it is not required to put a decimal every time. Once you put a decimal, all these numbers are considered as your quotient after the decimal point, right. So, again 0, 3 3s are 9. So, you will notice that this list continues. So, 10 upon 3 is equal to 3.333 and so on, right. So, the remainders, let us see the sequence of remainders. We have 1, 1, 1, 1 and the list goes on. Right, and the quotient is 3.333 and so on, as well as my divisor is 3. Now, there is a reason why I am denoting these points, but we will see that later. But let us go ahead in the meantime and solve the rest of the decimal expansions or the rest of the rational numbers and find their decimal expansions, right. So, the second one is 7 upon 8. We are going to solve this in the similar manner. So, let us check. I have 7 inside, 8 outside, 8 zeros are 0, I get 7, okay. I put a decimal here and I take a 0. Now 8 7s are 56, 8 8s are 64, 8 9s are 72. So 8 8s are 64. 70 minus 64 would give me 6, right? Again I put down a decimal, so 8 7s are 56 and I'm left with 4. Again I'm going to put a 0 over here, 8 5s are 40. So I got my remainder as 0, right? So my quotient list ends over here. So let us write down these points. I have my remainder. The sequence of my remainders are as follows. I have 7, I have 6 and I have 4. Okay, my quotient is 0.875 and my divisor is 8. Right? Now we'll take a look at the third one, which is 1 upon 7. I do not have space over there, so I'll do this over here. Okay, so the third one, 1 upon 7. So let's check. I have 1 inside and 7 outside. So 7 zeros are 0, 1. I put a decimal point here and write a 0. So 7 ones are 7, 3. Take a 0, 7 fours are 28. 30 minus 28 would give me 2. 7 twos are 14. 6. 7 eights are 56. I'm left with 4. Again I write a 0. 7 6 7 5s are 35. 5. Okay, I do not have much space. Let us just redo this. I'm writing the question over here, okay? 10 upon 3, 7 upon 8 and 1 upon 7. So we are going to check 1 upon 7 quickly. 7 zeros are 0, 1, 7 ones are 7, 3, 7 fours are 28, 2, 7 twos are 14, 6, 7 eights are 56, 4, 7 fives are 35, 50, then 7 sevens are 49, 1, 0, 7 ones are 7, 30. See, look over here now. We had a 10 over here which is repeated, right? So the sequence is going to repeat. If you notice, I have a 1 here, now I have 30. So I will write 4, 7 fours are 28, right? And I'll be left with 2. So the pattern will repeat. So here for 1 upon 7, what do I have? My remainder sequence is it is 1, 3, 2, 6, 4, 5. Again the same thing. 1, 3, 2, 4, 2, 6, 4, 5. So let me just write this. 1, 3, 2, 6, 4, 5. Then again 1, 3, 2, 6, 4, 5. So this sequence is going to repeat after we get 5 in the remainder, right? Again it will switch to 1, then 3, 2, 6, 4, 5, then again 1, 3, 2, 6, 4, 5. Okay, let us see our quotient. My quotient is 0.142857 14 2, 8, 5, 7. Again, the sequence will repeat for my quotient as well. And my divisor is 7. Right? Now let's count these numbers that are getting repeated. 1, 2, 3, 4, 5, 6. So 6 of my numbers in the quotient are getting repeated. So what do you observe? What is your general observation? When you divide rational numbers, the numbers that you get after the decimal, they either terminate or they keep on recurring repeatedly, right? See, this entire sequence is repeating. So you have something that is terminating over here, right? We get a remainder as 0, therefore my quotient is also terminated. Over here I have 3 recurring all the time, and here I have a sequence that is repeating. Recurring is nothing but repeating. So my general observation is, I'm just erasing this portion. What do you notice? The remainder sequence ends at 0, right? We have, take a look at 7 divided by 8 or 7 upon 8, okay? The second observation is the remainder sequence keeps on repeating. Also, when the remainder sequence keeps on repeating, remember that we counted the number of digits that are repeating over here. These are 6, right? So in case of 7, there are 6. So the number of digits that you will have in your quotient will always be less than that of the divisor. So this is going to be my third observation. The repeating numbers in my quotient are always less than the divisor. So by less I mean the number of digits here, 1, 2, 8, 1, 4, 2, 8, 5, and not 8. You will wonder that we have an 8 here, but the divisor is 7. So I am not looking at the numbers, but I am counting the number of digits that are repeating. Got the difference? So in case of rational numbers, we have either terminating decimal points or terminating decimal quotient numbers, or we have something that is repeating. So there are terms given to these, right? Let us write them down. In case of decimal expansions of rational numbers, we have terminating decimal point numbers, or what? We have recurring decimal point numbers. Right? So this was the case of rational numbers. Now we know that irrational numbers are complete opposite of rational numbers. So in the case of irrational numbers, you will not have terminating decimal point numbers as well as recurring, there won't be any recurring decimal point numbers. Okay? So let me just give you an example of this. We have root 2 whose actual value is for irrational numbers. Okay? This is for rational numbers and for irrational numbers. So we have root 2 whose actual value is 1.414213562309504881, and it keeps going on. So you see over here, root 2 is an irrational number because the decimal point after the numbers are not getting repeated over here, right? We have 414, 213, 56. So nothing is, there is no really a pattern, okay? There is no pattern whatsoever, as well as my decimal, the numbers after my decimal point, they are not ending at all. Also, another example is root 3. We have the value as 1 point, we have pi as 3.14159265358979323 and so on. Again, the decimal list keeps going on, it doesn't end, and there is no repeating pattern. So this is the major difference between decimal expansion of rational and irrational numbers, and a major difference between rational and irrational numbers itself. So we will take a look at the remaining examples, solved examples, as well as exercise 1.3 in the next class. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.